Alright guys, here's Wednesday's assignment. We are working on properties of logs. This is still section 5.4 in your book, so if you need to go and look at any resources, it will be in that section. Today we're specifically covering three properties: the product property, the quotient property, and the power property. And they're all very similar to the exponential properties we've done before. If you are not taking notes on this, I would make sure I have a picture or a way to access this, because it'll be very helpful for your homework, so you can always pause and write this down as well. So basically what the product property says is that if I have the log of the same base of two things multiplied together, I can split it apart as long as I have log the same base of m plus n. And so just to remind you of an exponential property like that, it's if I had something like x squared times x to the third. We know that we add those exponents. That's where this property comes from. And so then the opposite of that would be division. If I had the log of m divided by n, or some function divided by another, I can split it apart into subtraction. That would be like x to the 6 divided by x to the third. We know that's x to the 6 minus 3, which is just x to the third. So it would be subtraction with exponents as well. And then the last one looks a little different, but it's the power property. And I'll be talking about these as we go through the examples. But if I'm taking the log of something that has an exponent attached to it, I can bring that exponent out front. These are going to be used to solve logarithms, and they're unknowns, a little more difficult than what we had in yesterday's homework. All right, so moving on to some examples, and I'll tell you which property we're using. So if you wanted to have your page open in your book to the properties of logs, or you've written them down, that might be helpful. All right, so in example A, we have addition. So addition should remind you that that is multiplication. So if I want to write these all as a single term, we call this expanded term. I'm going to have, let me move it over so I can write on this, log base 2 of 7 times 5. That just simplifies to be log base 2 of 35. All right. So with numbers, it's pretty easy to simplify, but we can see in example B, we're not just taking the natural log of numbers. We have the natural log of numbers and variables mixed. And then we also have this 2 out here in front. That 2 is where we are going to use our power property. So I like to do, when I have multiple properties going on at once, take a couple steps to do them. So if I have a 2 out front, that's really as if it was an exponent attached to that x. So this is really natural log of x squared plus the natural log of x plus 6. All right, so it's addition. So what do you think that is? Take a moment and think about what property that is. Addition represents multiplication, so I can really say this is the natural log of x squared times x plus 6. And then I would want to distribute. I would want to simplify this as much as I could. So I'm going to get the natural log of x cubed plus 6x squared, and that's fully simplified. All right, so we got one example like this. It's subtraction. So subtraction should make you think division. So I can rewrite this as log of x plus 2 divided by x. So if you had multiple of these, you would want to just go in order, and you would also want to make sure you're thinking about order of operations. All right, so if we start as a single term, they sometimes want us to expand our terms. So this next example here is just kind of easing us into expanding our terms. We're only using the power property that says my exponent can really be written in front as multiplication. So in A, we could rewrite this as x natural log of 5. So that's A. For B, my exponent is all of this. So we could write this as x plus 2 times log of 32. This can be distributed, so we could really write this as x log 32 plus 2 log 32. Knowing that log 32 is just a number, it's probably an ugly number with lots of decimals, but it's just a number. All right, and C is a little trickier. What can we write this square root as that would be an exponent? I'm going to pause, let you think about that. We can also say that this is log of x to the 1/2 power. So we're going to want to get used to thinking of square root as a fractional exponent of 1/2. And now that can be multiplied up front, where my final answer would be 1/2 log of x. Right, so if you have any questions, just make sure you are noting them in your notes. Things that you want to ask me later, you can always refer back to this video as many times as you need. But I'm going to move on to writing our expressions expanded. So just like how we had expanded expressions here and we wrote them as a single term, we're going to want to take ones that are single terms and we want to write them expanded. And if we look at our example A, I can see I have the product property going on because I have x squared times z, which means I'm going to have some addition, but I also have this exponent. So I'm going to work backwards. I'm going to split up my two terms of x squared and z first, knowing that those are multiplied together. So I have log of x squared plus log of z. All right, that is pretty well simplified, but when they really want me to write it as a simplified, fully simplified, expanded term, they want to not have any exponents as well. So I'm going to use the power property and know that I write that out front. So I have 2 log of x plus log of z, and that's my fully expanded form. All right, take a moment and finish noting that. See if you have any questions on that. And then here is our last example for this video. And again, we've got that square root. So right away, we need to think of rewriting that as a fractional exponent. So x divided by x plus 5, all to the 1/2 power. All right, so I can't do anything with the terms of x divided by x plus 5 because they are either to the power of 1/2 or they're in the square root. So I need to bring this 1/2 out front first. So 1/2 natural log of just x divided by x plus 5. Now I can do something with the x divided by x plus 5. Division represents subtraction, but here's the little trick here. Because x divided by x plus 5 was all to the 1/2 power, when I rewrite it, I need to bring that 1/2 out and make sure that I'm distributing it to both of my terms in my subtraction. So natural log of x minus the natural log of x plus 5. Right? And if I wanted to, I could go ahead and distribute, but I would accept this as an answer, or 1/2 natural log x minus 1/2 natural log of x plus 5. All right, that's it for today. Today's assignment is fairly short, so ask me questions, look in the book, get together with your friends. Right now I can't have anyone come in and get help in person, as our superintendent has said no. I will let you know if that changes. Hope you're having a great day. Miss you all.